All right, we've got 4 practice questions here at the end of this topic, number 1 of reactor theory, called neutrons. I've noted and already put in a request to be changed. This should be a exponent. That should be 1 times 10 to the third right there. So on this first question, let's solve it. It says during a brief time near the beginning of cycle that I have delayed neutrons equal to 1 times 10 to the third. So neutrons delayed, I have 1 times 10 to the third, and they said this is occurring at the beginning of the cycle. So it asks me how many neutrons prompt would be there. Well, what I have to figure out is what is the delayed neutron fraction of the core. Remember that? The beta of the core? And we said at the beginning of core life, the beta of the core, the delayed neutron fraction, was about 0.0070. It represented about 0.7%. So this is the delayed neutron fraction. The prompt neutron fraction was 99.3. So what they're saying is that the fraction of delayed neutrons, that is 0.7%, is equal to 1,000. If I have 1,000 delayed, and that is the percentage of delayed, what is the prompt? Well, here's what I know. Neutrons total equals neutrons delayed plus neutrons prompt. And they're asking for prompt, not delayed. And here's what I also know. We've rounded this number. A better number for this question, I know, instead, it's going to be 0.0064, only 64 out of 10,000. We're actually going to lower it. The delayed neutron fraction was actually 64 out of 10,000. And you're just going to, I know it's frustrating, there's no common number. We round that to 0.7 because sometimes you'll see 65 out of every 10,000, so the beta of the core is that. So we just generally will round like this. Well, if you round here, it's going to be a little bit frustrating. So here's what I know. If the total neutron population is equal to delayed plus prompt, and I know that the delayed population is equal to 0.0065, which is 0.65%, times the total neutron population. So then I can find out the total by dividing the delayed by 0.0065. So we're going to do that. So the total neutron population equals 1,000 divided by the delayed neutrons fraction of 0.0064. And if I do that on my calculator, I'm going to get a total population equal to 1,000 divided by 0.0065 equals, must have messed something up, 1,000 divided by 0.0065 equals about a 1.53 times 10 to the 5th, and that's total neutrons. But it asks me delayed neutrons. Delayed neutrons. So I have to subtract 1,000 from this, right? So this is 153,000 essentially. It would be 152,000 that are prompt because the total is 1.53 times 10 to the 5th. Right? So we're going to look for an answer that is that. On our equation sheet, lo and behold, the first answer is 1.5 times 10 to the 5th. Answer alpha. So in reality, just got to be careful. Are they asking for the prompt neutron population or the total neutron population? And here, you sometimes are going to have to work out different values if they're not given for the beta of the core at the beginning of core life, where we generally say it's 0.7%, maybe it's only 0.65%. So that can get frustrating, I know, but just work with them. Get used to the practice questions, and you'll know when to use what numbers.